サテライフ。
地球の皆さん、こんにちは。サテライフの田中です。今、ドイツにあるエアバス社で開催されているアースケアに関係するイベントに来ています。で、今回はアースケアプロジェクトに15年以上、携わっている伊佐野小塚さんに来ていただいています。Hi, Kotsuka-san. Thank you for giving us this interview opportunity. So first, could you introduce yourself?
Thank you, Toshi-san. My name is Kotsuka Wallace. I'm the EarthCare Mission and Optical Payload Manager. So I've been working on the development of the optical instruments since the development started and getting them built and delivered and integrated onto the platform. And also now looking after the whole mission segment, so the ground segment and processing the data and having it ready to get to the scientists.
Thank you so much. So can you share your story related to this AskCare?
Well, I started working on EarthCare in 2008, so I kind of consider it my baby, my big baby, because I started with the smallest instrument, the broadband radiometer, and later I was looking after also the multispectral imager, so the two passive instruments, and then I became the payload manager, so looking after all three of the European instruments that are on board, and latterly also the whole mission. So that's been a learning experience for me. So I do consider it a very big chunk of my life because it's been 15 years. And I'm really excited now that we're getting close to the launch. And I hope everything's going to go well. So I'm slightly nervous as well, but very excited.
That's sweet. Then can you explain the 4 instruments on board the AskCare satellite and how all the instruments work together?
Sure. So we have our two big active instruments. We have the cloud profiling radar that comes from Japan, and it's a Doppler radar. So it's able to take a profile deep into the clouds and tell us information about vertical motions of precipitation particles in the clouds. So we get a big amount of information at a microscopic level deep inside the clouds. Then we have the atmospheric LiDAR. It works on a similar principle to the radar. Instead of probing with a radar signal, it probes with an ultraviolet laser. So we chose ultraviolet because it's high spectral resolutions. That gives us a clearer, higher resolution picture of inside the atmosphere. Of course, we can't probe with light into a cloud. You can't see through clouds with light, but we get some information from the top of the cloud, and we get information about the aerosol particles that are in the atmosphere. So these two active instruments collect data from a rather thin curtain underneath the satellite. We have a multispectral imager, and that's a much wider swath. And that gives us the context of what are we looking at? What do the clouds look like? It also retrieves some aerosol data. And later, it allows us to extend the information over a wider area. So this microscopic data is fed into models. And from the models, the scientists are making a prediction of what is the radiation balance, what are the fluxes at the top of the atmosphere. So that's the reflected sunlight that leaves the Earth and the thermal infrared radiation that's radiated away from the Earth. So this is the prediction that comes from the models. But we also have a broadband radiometer that's taking an actual measurement of that data. So then we can compare what comes out of the model against what we measure, and it allows the scientists to improve their models by looking at the truth.
Thank you so much. That's great. What were the major challenges during the mission, like development phase, and how did you overcome?
It feels like EarthCare was just one long series of challenges. Each of the instruments had their own challenges. On the broadband radiometer, we had quite a few issues with the mechanisms. For instance, we had to build 3 life test models of the mechanism with small design changes each time and a small operational change. But we overcome that problem, and BBR was delivered and integrated on the satellite 2017, 2018. On the multispectral imager, it's really 2 cameras, a thermal infrared camera and a more visible channel-oriented camera. On both those cameras, during the calibration of the cameras, we found problems with the hardware. So we had to make a hardware change of some of the optics in one of the cameras. We had to make a hardware change of some of the thermal control and one of the mirrors to collect a calibration view on that camera. on ATMID, our big atmospheric LiDAR, it's a very big instrument. It arrived during COVID. It was a major problem. We had to manage to integrate the instrument onto the satellite without the correct teams present. We had video feeds going between the sites. We were so happy because it's a very small clearance to get that instrument in. And then shortly later, we found a problem which we identified to be a very small, a few millimeters big component on a board. We had to take the whole instrument out, open it, take the units out, have them refurbished just for these two tiny components, replace everything, put the instrument back together and get it back on the satellite. So it was really a great achievement to manage that in a super fast time. So many development issues that we had to address and fix and find solutions for, and many exciting bits of work if you're someone who's interested in technology and technology developments.
Thank you. Now we can imagine how difficult such many challenges that you had. Yeah. And this is the last question for me. The ASKIA is the first joint mission. Can you provide comments on the importance of the collaboration between Europe and Japan and ESA and JAXA?
EarthCare is a very large and complex satellite. Its complexity means that without having an international collaboration, I doubt very much that we could have gone forward with the mission. It's not just the provision of the technical excellence of the radar, but it's the science community wanting. We have a very broad science community, having not just the Europeans, Canadians, but having our huge international community, including the Japanese component. And now with EarthCare, we know that we have a reliable partner. We've developed a cooperation and a trust between us. We have working mechanisms in place now for frameworks for how to work together. Just at the technical level, we know how to work well with each other. So you really need to have these very big, complex missions, a reliable, trustworthy partner. And this we know that we have with our Japanese colleagues.
Thank you again for giving us this interview opportunity and sharing your story with related to ASKIA. Like you think of the ASKIA satellites sort of as a big baby.
Yeah.
That's a nice story. So thank you again, 戸塚さん。
Thank you, Toshi-san.
皆さん最後まで見ていただいてありがとうございます。もっとASKIAを知りたいとか、ちょっとでも面白いと思ったらぜひ、高評価ボタンとチャンネル登録よろしくお願いします。では最後に行きます。3、2、1、サテライフ。